All right. Now, the solar system in order of average distance, you need to know the order of the planets, starting with Mercury being the closest to the Sun, Venus, then Earth, then Mars. Then there's an asteroid belt we'll talk about a little while in near the end of the chapter. Then Jupiter, Saturn, Uranus, and Neptune. So you need to know the order of the planets from the Sun. All planets will rotate, and they rotate around an axis, and what is odd is that they all rotate in the same direction as Earth. There are a notable exception. Venus rotates the opposite direction, but there is a reason we believe why. And so let me see if I can get these to work. There is the Earth rotating, and so this is the way that we rotate. Venus is rotating very slowly in the opposite direction. So all the other planets are going in one direction, Venus is in the other. The last one's hard to see. It is Uranus and, where is it? Okay, there's a little piece that you can see. It's actually rotating like this. It's on its side. Its axis, where we are not directly up and down, we're 23 degrees off, 23 and a half. Uranus is actually 90 degrees, so it looks like it's spinning on its side, but if you put it back up to its original place, it's spinning in the direction that we are. Venus, again, I'll come back to the rationale why we think Venus is going in the opposite direction. We think something happened to Venus. Something of that is similar to all of the planets, or most of them, is that if you took a look at the edge of the universe, almost all of the planets are in what's called the same elliptical orbit, okay, with the exception of who? Okay, this is one of the reasons Pluto got kicked out. It didn't look like the other ones. The category in which Pluto was placed into, all of their orbits look like this. And so the fact that they are all on the same plane actually goes back to how we think the solar system was created and why all the planets are spinning relatively in the same direction. The inner planets are Mercury, Venus, Earth, and Mars in order of closest to farthest away from the Sun. They are relatively small, and what we know about these, they are made up of the rocks, the rocky planets, sometimes we call them. Most of them have cores of iron. Between all four planets, there are 3 moons, one around the Earth and 2 around Mars. Okay? Mercury and Venus have no moons. Also, they have relatively, okay, you can say it 2 ways. They have long days, or they have slow rotation around their axis. So it takes a lot of hours for them to have one full day. That's going to be different than the outer planets. The outer planets, which include Jupiter, Saturn, Uranus, and Neptune, are much larger. They are all much, much less dense, meaning that there's not a lot of weight for all that volume, and there's not enough weight for them to be rock. They are actually gases that are collected together. And so from Mercury, Venus, Earth, and Mars, we could send a spaceship and conceivably land on the surface. If we sent our spaceship to any of the other planets like Saturn or Jupiter and we try to land, what we would do is go into a cloud layer and continue to sink and sink and sink until there is no surface, but the pressure of the gravity would crush the spaceship. And so there is an idea that because there is so much gravity, that even though it's all gas near the center, the gravity pulls it into a liquid and or solid form, some core in the middle, but there is no rock that composes them. You can say it 2 ways. They have very short days. or they have very rapid rotation around their axis, and there are over 80 moons represented between those last 4 planets. And so the majority of moons are around the outer planets, not around the inner planets. Okay. Comets are items that also orbit the sun. Comets are really kind of a strange thing. Does anybody know a name of a comet? There are a couple famous ones. Halley's Comet. Halley's Comet was seen probably 20 or 30 years ago. Won't be seen for another 50 or 60 years. And so comets are very small bodies that have what are called elliptical orbits, or they have really long, really oval orbits. And so most of the time they spend their lifetime very far away from the sun. We don't even see them. They are composed mainly of frozen gases, some rock in them, and when they approach the sun, they tend to melt. And what happens is the material converts into gas, and that gas is given off because it's being warmed by the sun. And as it gets closer and closer to the sun, remember, you go fast when you go by the sun and you're slow when you're very far away. They go fast around the sun, and as the sun's material comes and hits them, all that gas that is evaporating creates a tail. And so when you look at the night sky at a comet, what you see is this blurry smudge because you see the entire gas tail that is being pushed away by the sun's material that's coming off. And so comets are ones that melt when they get close to the sun, have very elliptical orbits. You can think of them almost as dirty snowballs. One thing about comets, we believe that comets are created or made from the original material that created the entire solar system. And they are big snowballs that have been melting ever since the solar system has been created. They've not melted away, but they haven't melted away yet because they only get heated up a very small fraction of their entire lifetimes. Okay, so comets are approaching the sun, and most of the time we can't see them, but as it gets closer to the sun, the tail gets longer, and if you can see, the tail is always pointing away from the sun, not following the direction like where the comet is. So it isn't like I'm running with a cape and it's behind me. If the sun is there, then my cape gets pushed that way. It's always being pushed out by the sun from which it's being created. Now, the one thing about a comet, as it is being evaporated by the sun, it leaves all sorts of stuff in its wake. So every time a comet goes by, it leaves stuff behind it. Kind of like a really messy roommate, they just leave stuff behind. Okay? Now, that will get us to the point if by chance an orbit of a comet who has left all this dirty stuff in the way, if we run through that in our orbit on Earth, we get shooting stars in the night sky. And so you can understand why we have meteor showers that happen every year at the same time. It's because a comet has gone through this part of space and the Earth goes through it, we have a meteor shower, and we don't hit that until it takes all the way around the sun or a year later. So we always hit where that comet was every year, and we would have a shower of meteors that we can see. The shooting stars are all that stuff that's in the orbit of Earth that we hit, and that stuff hits our atmosphere and falls down. Now, sometimes there's just random things there, but the trails of comets that have passed the Earth's orbit leave a lot of the material that is there. Now, the fact that there is places where the comets and the Earth meet at some point in time, that this went first, but we came here, there's always the possibility that we would meet at the same time, and that could be very bad. Now, most of the things in terms of the shooting stars that you see are smaller than grains of sand, but they're coming very quickly, and they hit the atmosphere, and that friction actually burns them away. And so most of the time, the things that we encounter as the Earth hits them, they burn up. But every so often, whatever you hit might be large enough to be burnt up almost all, and then there's something left over that falls onto the Earth. A meteor, which encounters the atmosphere and gets burned up, is the shooting star, but a meteorite is what actually hits the Earth. So it changes its name when it hits the Earth. Two kinds, they can be all made up of rocks, and those are mostly silicates, just like the face of the Earth. And then there are others that are made up of metals, mainly iron, that can hit the ground. Now, the easiest place to find a meteor is in the Antarctic. Why in the world do you think it's easy to find a meteor there, much more than, let's say, around here? Okay, what do you think about the Arctic? When you think about it, what do you picture? What color is it? White, because there's lots of what? Ice, right? And the ice can be miles thick. If there's a rock on top of the ice, nowhere around mountains, how likely did that ice come a mile under the ice and come up to the top? Or how likely is it that rock fell from the sky and landed on the ice? Most likely it fell from the sky. So that's a meteorite. So they're easier to find there than any place else. If by chance a rocky meteor fell around here, good night. I hit so many rocks when I mow my lawn, I wouldn't know a meteor from another rock around here. It would be hard to identify. Okay? There was a whole show on the History Channel about meteorite hunters. What they did was they went to big holes where big meteors actually hit, and what they're looking for are little chunks that fell off before or that were blasted when the big meteor hit. And meteorites themselves actually go on the market for more dollars per gram than even diamond. So it's pretty lucrative if you can find some. And every so often we have people that call to Lee and say, I found this real rock. I want to know if it's a meteor. And I go, I don't know either. And there's no way for us to test that. And so, but they want to find a meteor. And it's kind of interesting that people call us for that. They call us to identify a lot of things that we don't have the ability to do. But one thing about meteors, though, most of them are magnetic, and that's one way to classify them as a possible meteorite, although that's not the only indicator. Now, most of the inner planets have been hit with lots and lots of meteors, okay? But we don't see that. If you actually look in the night sky, you do see the moon. And on the surface of the moon, what do you see lots of? Lots of craters. The moon is so close to us that the Earth also got hit with that many meteors. Okay? So the Earth should look like the moon in terms of lots and lots of craters, but because of tectonic motion and erosion, we don't see a lot of those craters anymore. On the moon, there's no erosion, and so we see, if there's an impact, we'll see it for the rest of time. And so we can see those kind of craters. In terms of the inner planets, for about 3 billion years, we think, and the age of the Earth is 4.5 billion years, we hit lots and lots of debris and had lots of meteor strikes up to that point in time. After about 3 billion years, we went around the sun enough that we hit just about everything we could. And so we have this little track that we follow that there's not much stuff there anymore to hit. and so most of the planets are the same way that are on the inner planets. All right.